two nails are driven into the vertical pole at the same height. A weightless inextensible thread is attached to one nail. A small ring is put on the thread. The other end of the thread is thrown over the second nail. Two identical weights are attached to the ring and to the free end of the thread. Determine the acceleration of the loads. Here we will not consider the friction as it is already given in this question. Now let's solve the question. Let's see how motion occurs. First, suppose this angle is alpha, and suppose the tension in the string is T at equilibrium. So for the equilibrium of the right block, the tension must be equal to the weight of the block. So T must be equal to W for the equilibrium. And this is same for the left block. In the equilibrium position, the net force on the left block will also be 0. So here we are balance. I am going to balance the net force in the vertical direction on the left block, which will be equal to 2t cos alpha is equal to W. Now I am replacing t by W, so I will get this equation, and then cos alpha is equal to half. So from here we conclude that the angle at the equilibrium, then the angle at the equilibrium will be 60 degree. Now suppose these lengths are x, y and x. Here x is the length between the left block and the right nail, and y is the distance traveled by the left block from initial to this position. Now consider this right angle triangle. Here I have drawn this right angle triangle. As the left block moves downwards, how this right angle triangle will change? It will change like this. The hypotenuse is x and the distance traveled by the block is y here. Now I will apply the Pythagoras theorem for this right angle triangle. It will be x square minus y square is equal to c square, where c is the third side, or we can say the constant side. I am applying the differential operator on both the side. We will get this and then this. I am again applying the differential operator. Here the differential operator is just the derivative of the parameters with respect to time. So I will get this. There are some terminologies which we will keep in our mind. Here y dot is the velocity of the left block, which is denoting by v1, and the y double dot is the acceleration of the left block, which is a1. Similarly, v2 and a2 are the velocities and acceleration of right block. Now consider this length is L. So because the thread is inextensible, so the total length of the thread will remain constant throughout the motion. So 2x plus L is equal to constant. Again applying the differential operator on both the side, we will get this. So 2x dot plus v2 is equal to 0, where v2 is the velocity of the right block. Because like L is length of this thread from right nail to right block. So as L change, the position of the right block will also change. So I have denoted that the derivative of L will be the velocity of the block 2 or right block, we can say. Again applying the differential operator, we will get 2x double dot plus a2, acceleration of the second block or right block. Now keep in mind these four equations. Here the angle 60 degree is the equilibrium angle. So for equilibrium, x must be equal to 2y because the angle is 60 degree. So by simple trigonometric relation, we can find relation between x and y, which is x is equal to 2y. So from these two equations, we will get this. By further simplifications, we get this, and in the end, negative of velocity 2 is equal to velocity 1. And from these two equations, we will get this, and then this. By further simplification, we get this. Here I am replacing the acceleration of the second block by the acceleration of the first block at equilibrium. Why I have done this, why I have replaced the acceleration of second block by the acceleration of the block 1, you have to answer me in the comment box. Let's see how many of you can write the correct answer, that why I have replaced the acceleration of second block by the 1. Again, further simplifying the equations, we will get this. So this is our important result. Now let's use the energy conservation law. Here work done by the gravity will be the gain in kinetic energy for the blocks. So work done by the gravity on the left block will be positive because the block goes downwards or towards the earth, so the work done by the gravity must be positive. And the work done by the gravity on the right block must be negative because it travels or it goes in the opposite direction of the gravity, or we can say uh, uh, outwards from the center of the earth. So here uh, the y, the distance y traveled by the block left block, or traveled by the distance by the block 1, which will be equal to x cos alpha. And here I have replaced y by the x cos alpha because by simple trigonometric relation we can find this. Similarly, delta L is just the change in the thread, change in the length of the thread. And what length? The length is from right nail to right block. So the delta L will be equal to 2x bracket 1 minus sin alpha. You can calculate this easily. I am skipping the calculation here, and by cancelling out the common factor m, we will get this. At equilibrium, I am remembering you again that at equilibrium v1 is equal to minus v2, alpha is equal to 60 degree. So v1 square is also equal to v2 squared. Now by further simplifications, I am skipping some calculations. We will get this by putting the value of alpha is equal to 60 degree and v1 equal to v2. We can get this easily. Now combining these two important results, we will get our answer, which is equal to a1. Here you have to tell me what negative sign represent. What it is representing. So you have to answer two questions. The first question is why I have replaced a2, which is the acceleration of the right block, by the a1, which is acceleration of the left block at equilibrium point. Because throughout the motion the acceleration of both the block will not be same, but at equilibrium point the acceleration of both the blocks will be same. You have to tell me why. Also, what does the negative sign represent here in the final answer? You have to tell me. You can type your answer in the comment box. Thank you for watching. Thank you again.